So we have completed the loading and boundary condition application. Now let's do the post-processing. So in post-processing, the first step is we evaluate that whatever applied behavior are, that should be reflected in output also. Means if you are pushing the rod like this, it should bend like this, right? So let's check out the deformation shape. Yes, so deformation shape is matching with our judgment, right? So if you are fixing at this 2 and if you apply the uniformly distributed load, it should bend like this. Here the slope is 0 because this is a fixed end, right? So you can see the straight line and then it's moving. Here we have applied the roller support, so it's having direct slope here. And next, let me play the animation and see how it's being deformed, right? Another part is how we have to check whether the essential boundary conditions are met or not. So we can check from the probe. If you are not able to see this 3D way, you just go to display and just tick under the style thick shell and beam options. Under the probe, I will go there and will see the deformation at this point. It's 0, right? So here it's fixed support. It indicates the essential boundary condition is satisfied. So fixed support, the displacement will be 0 mm. And we'll also check the equilibrium. We'll drag and drop this fixed support and displacement by clicking a shift on keyboard, and we'll drag and drop to the solution. So this reaction are called. I will just right click on this reactions and we'll say rename based on definition. So this reaction is of fixed support and this is a reaction at this displacement. We'll say evaluate this results, right? So here, so on this end we are getting 250.98, so let me write down 251 pound force, and on this end, right hand side end, again y force is 151.52. So here it is 151.52 reaction in y, by, and this is ay. Now let's find out how much line pressure we have applied. We have applied a line pressure of 35 pound per feet. If we click on this edge, its length is 11.5 feet, right? So it means that the applied force will be like in this direction. Fy is 35 pound per feet into 11.5 feet. That will give us 402.5 pound, right? So applied force is 402.5 pound. Reaction here we are getting 251, here we are getting 151. If we'll sum up this both, we will get the 402.5, right? So applied force and reaction force are matching. So we conclude that this is in a equilibrium condition. Next, I would like to see the shear force and bending moment diagram. For that, make sure you have selected edge first and then ask for the result. So I will go to the edge selection filter, we'll click on this line body, and then we'll go to the beam result and we'll select shear moment diagram, right? So automatically it makes path. If you have not selected this edge filter and selected edge, then it will not make a path, you will get error. So we'll right click and we'll say evaluate all result. So shear force and bending moment diagram will appear in front of you. So here the total shear force, maximum shear force is 247.32 pound. The maximum bending moment is 571.94 pound per feet at the fixed support. The total maximum displacement is 6.084 into 10 raised to minus 5 feet at 6.69 feet. So here we can see the shear force and bending moment diagram. Now here you can see that it's a step. So we have divided into 50 points, so therefore 55 points, so we are getting the results in that fashion. So if you want to have more number of points, then what you can do is either increase the mesh size. So we are going to increase the mesh size, number of division, let me keep as 100, and let me resolve this. Right, so this has become little more smoother than what we have expected, but the result are not affected that much, right? 572.07 and 248 are the nearby to our last result. So we have also checked that mesh independent test, that changing the meshing is not significantly affecting our results. So this was the shear force and bending moment diagram, which you can find out. Alternately, you can see the toolbox and beam tool under the this I will delete, and will say what is the stress being generated in it. You can find out that part also. Next, we are going to verify this result with our hand calculation, what we are getting, and we'll see the ANSYS result and how hand calculation results are matching. So that's very important stage of verification. We have done a sanity check that essential boundary condition at this fixed point is satisfied. We have checked the equilibrium also, that the applied loads and reactions are also matching. We have also checked that changing the mesh size is not significantly affecting our results. And the last fourth verification stage is comparing with some hand calculation or some analytical methods.